Alright, so the last video in this particular chapter is going to be looking at some more properties. And so we're going to be looking at something called a tangent and a chord properties. So first things first, a tangent. So a tangent is a line which touches a circle just once. Okay, so if I was to draw a circle like this, a tangent is a straight line graph which just crosses the circle only one time, like this. Another tangent graph or line could look something like this, only touches once. And another one could maybe look like this. Okay, these are all tangent lines. Okay, and they're all a straight line equation. Right, certain properties about this tangent line is that, well, if I know the center of the circle, then the tangent is actually a perpendicular to the line to the center. Okay, so all these tangent lines, they're all going to be perpendicular to the center, the line to the center, essentially. So that's how we relate, or how we go about finding the tangent line. Because if we know the line to the center, then we can use the perpendicular relationship and find out the gradient of the tangent. The other thing that we need to be aware of is chords. So a chord is just a line which connects 2 points on a circle. So once again, if I were to draw a circle and I draw 2 points, like here, this is known as a chord. So it could be any 2 points. So this is also a chord like this. This is also a chord, as long as it connects 2 points on a circle. Now the property related to a chord as well, the perpendicular bisector, which we looked at in a previous video, of the chord will always pass through the center of the circle. So once again, the perpendicular bisector will pass through the center like this. This one will pass through the center like so. And the black one would also pass through the center like this. So just that's the way we relate a chord, or what a chord allows us to find in terms of a circle. And so using this knowledge and the previous knowledge we've learned before, we can now solve a lot of examples or example questions related to circles. Okay, so let's try this final question here. So we have a circle with the equation x squared minus 4x plus y squared minus 6y is 7. The line L with the equation x minus 3y plus 17 is 0 intersects the circle at the points P and Q. Find the coordinates of P and Q. Well, they're intersecting, right? So we just have to substitute our line equation into our circle equation. So rearranging for x, we have x is equal to 3y minus 17, which I'm going to substitute into the circle equation. So 3y minus 17 squared minus 4 times 3y minus 17 plus y squared is equal minus 6y is equal to 7, which I'm now going to expand. So we'll get 9y squared minus 102y, 17 squared is plus 289, minus 12y plus 68 plus y squared minus 6y is 7. Now I'm going to simplify even further. So we'll have 10y squared, we'll have minus 120y, and then we'll have 128 plus 350 is equal to 0. And now it's just a matter of finding y. So dividing everything by 12, like this, and then now I can factorize it. So we'll get y, this can be minus 5 minus 7 is equal to 0. So y values are 5 and 7. Remember, it's a coordinate, so we need to find the x values as well. So plugging into the x is 3y minus 7. So x will get, if you plug in 5, we'll get 15 minus 2. If you plug in 7, 21 minus 4 is 4. Okay, so the p's coordinate is the negative one, so it's going to be minus 2, 5, and q is going to be 4, 7. Okay, so this part is what we've been doing previously in the previous videos. Right, B, find the equation of the tangent at the point P and the point Q. So we're trying to find the tangent equation line, right? So remember, the tangent was the line which only touched it once. So this one here and this one here, okay? So first things first, as it's a straight line equation, we need to find the gradient first. But we know that the gradient is 90 degrees to the lines connecting the center. So we're going to have to work at the center of the circle first. As you can see, the circle equation is not given in the general form, so we're going to have to complete the square to make it into the general form. So initially it's x squared minus 4x plus y squared minus 6y is 7. So we're going to complete the square. Dealing with x's and y separately or independently, well, x minus 2 squared plus y minus 3 squared is 7. So x minus 2 squared plus y minus 3 squared is equal to 7 plus 9 plus 4. So x minus 2 squared plus y minus 3 squared is equal to 20. So the center of the circle is 2, 3. Now, let's find the tangent for the p first. So we need to find the gradient of p. I'm going to call this c as the center. So we need to find the gradient of p to c first, right? So it's changing y by changing x. 3 minus 5 over 2 minus 2, minus 2 over 4, so minus 1 over 2. So that's the gradient of the line which connects p to the center of the circle. But remember, the tangent is at 90 degrees to that line, so the gradient of the tangent will be equal to minus 1 over 2, which is 2. So y is 2x plus c. Now we just plug in the coordinates of p, minus 2, 5. So 5 is equal to 2 times minus 2 plus c, so therefore c is 9. Y is 2x plus 9 for the tangent at p. Now it's the same thing for find the tangent at q as well. So we need to find the initial gradient of q to c. So q's coordinate was 4, 7. So changing y over changing x, so 7 minus 3 over 4 minus 2. So we'll get 4 over 2, which is 2. Remember, once again, we have to flip it or times it by minus 1 over because it's a perpendicular. So the gradient is going to be minus 1 over 2. So y is minus half x plus c. Once again, we now plug in the q's coordinate to find c. 7 is equal to minus 2 plus c, so therefore c is 9. So the tangent at q is minus a half x plus 9. Okay, so we use the property of relating a tangent to a circle. Okay, looking at C, find the equation of the perpendicular bisector of the chord PQ. So perpendicular bisectors, once again, we need to find the coordinates first, right? Or the gradient. So P was minus 2, 5, and Q was 4, 7. So we need to find the gradient first. So MPQ, we'll call it. It's 7 minus 5 over 4 minus 2, 2 over 6, which is 1 over 3. Now this is the gradient of MP to Q, but it's a perpendicular bisector, so we need to once again do minus 1 over 1 over 3, so it's going to be negative 3. So y is negative 3x plus c. Now to find the c, we need to find a point on that line, right? So because it's a perpendicular bisector, it means it's the midpoint of P and Q. So finding the midpoint would be equal to minus 2 plus 4 over 2 and 5 plus 7 over 2. So we'll get to 1, 12, 6, 1, 6, which I'm now going to plug into here to find my c. So 6 is equal to minus 3 plus c, so therefore c is equal to 9. So we have y is equal to minus 3x plus 9 as the perpendicular bisector equation of P and Q. And the final part is show that the two tangents and the perpendicular bisector intersect at a single point and find the coordinates of that point of intersection. So you just have to equate the line equations together, because we found this line equation here, we found this one here, and we found this one here, right? So just equate them together and then solve for x and y. I'm not actually going to do this one because this is fairly simple. It's just solving for x and y. So that's it for this chapter. We learned everything about to do with straight lines and circles and how they're related and how to find these intersection points. As long as you just remember the relationship between perpendicular and parallel and tangents and chords and how to find the center of the circle, then you should be able to solve all these different types of questions. If you guys still have some questions, then leave them in the comment section below and I'll try and answer them as soon as possible.